This one here is just a little way to highlight a particular identity I want to show you. So for example, v dot v, if you think about it, how do we typically write things that are multiplied by itself? There's a way that we write that usually, if we're multiplying two things that are the same. Yeah, to the power 2 squared, right? So we can say that's the same as v squared. And the thing you have to be careful of with vector notation is very particular. These two actually mean different things, right? Because this is saying I'm doing the dot product by itself, yeah? So I'm multiplying the vector by itself. What does this mean when it's got the absolute values there? Do you guys remember that one? What that is talking about? Begins with M. If you think about it, like, what does the absolute value do, actually? Yeah, so you're basically looking at the positive, right? So for example, -5, you take the absolute value, it equals to +5. Another way you can think about it is you can think about it as the distance from 0, right? So if I'm going from 5 or -5, the distance from 0 is the same. It doesn't matter which way I'm going, it's just looking at the distance. And this we call the magnitude of a vector. It essentially finds the distance of that vector, right? So that's what that's looking at. What you'll find, though, this is going to be very interesting, is that when we calculate these, there's an interesting relationship, because just recognize that these are different. But if I calculate v dot v, that would be, so I'm multiplying by itself, right? The x and y components, -1 times -1 plus 2 times 2, right? So what does that give me? It gives me 5? Hard maths. But if we do the magnitude of v squared, do you guys remember how to find the actual magnitude, like the distance of a vector? Yeah, that's right. Because basically, think about it like this. If you got a vector here, -1, 2 would be something like -1 up, 2 across, something like that, right? Essentially what's going on is that, wait, -1 is down, sorry, what am I talking about? So it should be like this. Essentially what's going on is you've got a vector here where this length here is 1 and this length here is 2, and essentially you're going to be using Pythagoras' theorem to find out the length, right? And what we want to find is the magnitude of v all squared. So that's basically saying, okay, well, we've got our x component and our y component, but I'm squaring this whole thing. What do you guys notice, actually? It's just the same. Yeah. So that's going to be √5 all squared, which is the same as 5, right? So what that means is we have a little identity, right? So an identity is that if we are taking the dot product of a vector by itself, that's going to be the same as the magnitude all squared. Okay, so here's a little identity for you. V dot v is equal to the magnitude of v all squared. And this is really important when we look at things like geometry proofs and things like that, because basically we can't really take things for granted. We can't just say, oh, you know, there's a squared here and multiply by itself, so it seems like they could be the same, because actually these are different means. This is the magnitude all squared, and this is the dot product by itself. Those two are slightly different things. Yeah, just make a note of that one there.